My name is Dr. Mack, and I'm teaching Physics 115 at Ohio Wesleyan this semester, that being Principles of Physics, or Introductory Algebra-Based Physics. And so I wanted to experiment with a bit of video capture to see if I could give you, the students, a bit of a summary of what we talked about in lecture today, so that you can have this to fall back on as you're looking through your notes and getting yourself confused, potentially, but hopefully not. So I just wanted to actually talk a bit about what we talked about in class today, which on the first day of class was going over the basics for the landscape of physics. Because we all know what math is, and math is the language of science, but there's meaning behind the math that is very important for physics, which is studying the world around us and how that actually all works. And in dealing with that meaning behind everything, we're going to talk about the units that we're going to be expressing our measurements of the world in. We are going to be following the SI system, where we have units of meters for length, kilograms for mass, and seconds for time. And oftentimes we're going to be dealing with the different SI prefixes, those typically being femto, meaning 10 to the minus 15, and potentially pico, 10 to the minus 12, nano, 10 to the minus 9, micro, 10 to the minus 6, milli, 10 to the minus 3, centi, 10 to the minus 2, and there are other ones in between there, obviously, but these are the most common ones that we'd be using for stuff that would be less than 1 for the multiplication. And then once you go above the regular standard term, then you would have kilo for 10 to the 3, mega for 10 to the 6, giga, 10 to the 9, tera, 10 to the 12. Now, in dealing with these units, it is exceptionally important to keep track of what those units actually are, and realizing that you can treat them as algebraic quantities, and you have to treat them as algebraic quantities. You can't say add 1 meter plus 10 centimeters and simplify this at all. That means nothing to simplify this, except for just 1 meter plus 10 centimeters. However, if you convert 1 meter plus 10 times 10 to the minus 2 meters, then you can add these and actually get something that simplifies into just meters. So this would be 1 meter plus, this means going back 2, so you have 1, 2, 0.1 meters, and so that would give you 1.1 meters. If you're dividing or multiplying, then this is even more apparent that you can treat them like variables, because they'd be able to cancel out. Say you're taking an area and you want a length times a width, and you have 4 meters times 6 meters to give you the area. The actual answer is going to be 24 meters squared. If this had been 4 meters and 6 centimeters, the answer you would have gotten is 24 centimeters, which doesn't really make any sense. You want to simplify things to get to the easiest way to express it. Okay. Something that we talked about in class today that, if you're not used to thinking in these types of units, could be tricky, is thinking about the density of water. And usually people talk about that in grams per cubic centimeter, but neither grams nor centimeters are the units that we're dealing with. We want kilograms and cubic meters, and so we need to be able to actually convert that into kilograms per cubic meter. So, in order to do that, let's deal with the grams first. We would multiply this by 1 kilogram over 1,000 grams. Because this is the conversion factor for kilograms and grams, because there are 1,000 grams in 1 kilogram. And you know to put the grams in the bottom here, because this G will cancel with that G. And so you're left with the kilograms, which is what you wanted to convert to. So now we have 1 over 1,000 kilograms per cubic centimeter. But we want this in terms of meters. So we must change this again. And now we need meters down here, cubed, instead of centimeters down here, cubed. And so we would multiply by some conversion factor that has centimeters cubed in the top, so that will cancel, and meters cubed in the bottom. And the way I like to do this is to put the simplest part inside and then cube the whole thing, since we have to take care of this 3 right there. So there are 100 centimeters in a meter, and then you would end up cubing that. So this would end up being 10 squared to the 3rd power is 10 to the 6th, or a million. So we get 10 to the 6th kilograms per meters cubed, since these centimeters cubed will cancel this centimeter cubed, divided by 10 to the 3rd from what we had before, since 1,000 is 10 to the 3rd. So what this simplifies to, as I'm running out of room here on the board, is actually 10 to the 6th divided by 10 to the 3rd is 10 to the 3rd, and so the density of water in SI units is 10 to the 3rd kilograms per meters cubed, which is definitely something that you don't often think about. You usually think about water's density as being 1, but it is not if you're looking at a different system of units. And you always need to make sure that you try to keep your units straight, because if not, then you're going to screw yourself up when you're going over problems. If you remind yourself that the answer you want is supposed to be a length, you should end up with meters or some other kind of centimeters, something like that in your answer. If you're looking for time, you better end up with seconds. If you're looking for mass, you most likely want kilograms unless the problem's asking you for grams. But if you get kilograms times meters divided by seconds, and you're looking for kilograms, something is wrong. So you need to look at that again. So, we're getting at analytical reasoning and problem solving a bit once you start thinking about these things, which will be very important with actually solving the problems that we'll be dealing with once we start describing things in the real world. Because physics is a bunch of word problems, as I kind of mentioned in class today. And so it's important to take what those problems are telling you and interpret them and be able to express them in math and then get at the deeper meaning behind that when you get to the answer. So that's what we'll be exploring, and you'll see more about that in class the next day.